As we begin to start thinking about statistical research and actually conducting some statistical research, there's some additional vocabulary that we need to be familiar with in order to understand that process and the setup and so forth. So, we're going to take a look at that in this particular video. The objectives for this lesson are that we want to distinguish between an observational study and an experimental study. You should be able to identify the independent and dependent variable within a statistical study, explain the difference between a treatment group and a control group, and then differentiate between a blind and a double-blind study. So those are the things that we want to take a look at and that you need to be able to do at the end of this particular lesson. So let's begin. Statistical research, the primary purpose, as we've discussed before, is to answer a research question or to answer some sort of question. And it could be a question like, does aspirin reduce the risk of heart attacks? Is one brand of fertilizer more effective at growing roses than another? Is fatigue as dangerous to a driver as the influence of alcohol? Typically, statistical research, in the attempt to answer the question, we're looking at or investigating the relationship between at least two variables. Now, you can have 3 variables, 4 variables, 5 variables, or so forth, but you have to have at least 2. And it's important that you set up your study from the beginning of the process because that proper design ensures that your results are going to be reliable and accurate. There are 2 primary different types of statistical research that is usually conducted, 2 broad categories. The first of those is called an observational research study. And some of the characteristics of an observational research study, the researcher merely observes or watches what is currently happening or possibly what has happened in the past, and then tries to draw a conclusion or answer the research question based on those observations. You can kind of think about an observational research study similar to people watching. You're simply observing what is taking place. Typically, you have very little or no interaction with the subjects or the participants within the study. There's really no manipulation performed. You're not trying to change the behavior or change what is going on. And that's what makes it non-experimental. The fact that it's observational is you're not attempting to change anything about the participants. And obviously, if you're looking at something from the past, you can't change that anyways. Because you're simply observing and you're not manipulating anything, you cannot really determine a cause and effect relationship. You can't say that one variable causes another when you're doing an observational study. Typically, observational studies are going to occur in a relatively natural setting, so again, sort of like people watching at the mall or people watching at the football stadium or the baseball stadium. You're more in a natural type setting, more so than a laboratory. Most times with an observational study, your data is going to be qualitative. It's going to be words, categories, phrases, written notes about behavior. Occasionally, you could get quantitative data, or you could have both. But more times than not, it's going to be qualitative. You can get quantitative data by using a survey, similar to the survey that you do at the beginning of the class. Some of the questions have you respond with a word, like your county of residence. Others have you respond with a number, like your age. The challenge with an observational study is it can be very expensive and time consuming because you often have to physically go to that location. You may have to mail out the surveys, and so you have the cost of the printing and the cost of the postage, and then waiting for those things to come back, be returned to you, can be time consuming. You see observational studies used a lot. It's very prevalent in the social sciences and also within marketing for the business world. They observe what brand of toothpaste customers buy, or what brand of milk they buy, or how many packages they buy, and that sort of thing. Again, some examples of observational research that you possibly can relate to are surveys, whether that's a telephone survey, a mailed questionnaire, or possibly even a one-on-one personal interview where you're asking questions of an individual participant or possibly a group of participants. You'll also see it in case studies, which again you see a lot within the world of business. So again, think about observational research study as people watching with very little interaction, and you're not trying to change any behavior. The second type of statistical research is an experimental research study, or we simply call it an experiment. Within an experimental research study, the researcher manipulates or changes one of the variables and tries to determine how that manipulation influences or affects the other variables. Okay, so you're making a change within one of the variables and observing what happens. Because you are performing some manipulation, there is typically interaction with the subject because you need to get feedback from the subject. Perhaps if it's a test or an experiment related to a new medication, you have to interact with the subject to, of course, give them the medication, but then also to get feedback on possibly any side effects they're feeling, or how they feel after they've taken that medication, or so forth. So there is interaction with the subjects. There are modifications. You're making changes, to the subjects. You're trying to affect or change the behavior or change what's happening for that subject. You're trying to maybe lower their blood pressure or lower their cholesterol level. Typically, an experimental research study is going to occur in somewhat of an unnatural setting because you have to very carefully monitor your subjects, and you want them to be in a controlled environment. So those often occur in laboratories. They can also occur in classrooms. Because you are looking at how one variable affects another, you can determine a cause and effect relationship. You can say this particular drug causes the blood pressure to go down. This specific diet lowers your cholesterol, those kind of things. So you can begin to determine a cause and effect relationship with an experimental research study. Experimental research is used a lot in fields like sociology, psychology, biology, chemistry, physics, and medicine. Some examples, and I've kind of already alluded to those, are obviously clinical trials of new medications, clinical trials of treatments, even trying different methods of teaching a topic within the classroom for the field of education, or trying different treatments from, if you have a psychologist, you're working with a psychologist or a psychiatrist to see how different treatments affect the patients. And then obviously lab experiments. So one of the first things you have to be able to do, one of the objectives, is to determine whether a given scenario is an observational or an experimental study. And so we're going to take a look at some of those. These are the type of examples you'll see on your practice problems, on your homework problems, as well as on your midterm or final exam. So scenario 1 says, subjects were randomly assigned to 2 groups, and one group was given an herb and the other group a placebo, a fake drug or fake herb. After a year, the number of respiratory tract infections each group had were compared. Okay, so if we stop and think about it and we're trying to decide, is this an experiment or is it observational? Well, I am manipulating the groups because I'm giving one an herb and the other is getting a placebo. So that is my clue that that is actually an experiment. Okay, and I'm going to see if I can write that up there for you. Okay, so the first one here is an experiment. Get my pen working. All right, so we have the first one is an experiment or an experimental research study. Okay, second scenario says GHC's president wants to know the average age of students enrolling in fall 2020. He uses the student records in SCORE to determine the age of each student. Okay, so he wants to know the average age, and he's using records within SCORE. He can't change or manipulate the age of that person, so this would actually be observational. He is observing the student's age from the records in SCORE. So this is an observation or an observational study. The third one, a researcher stood at the entrance of GHC to see if the color of the automobile a person drives is related to running red lights. In other words, does the color determine whether or not they're going to run a red light? And so they were standing at the entrance of GHC. They're not attempting to change the color of the automobile, nor are they trying to change whether they're running a red light, because they would obviously get run over. So again, this is simply an observation. I'm just observing what color of cars run the red light. And finally, the last one, it says a dentist wants to research the effects of a new dental material used to make fillings. Now, it doesn't elaborate, but if he's going to do that, I would anticipate that he would have to know the effects of the old material, and then he uses the new material and looks at those effects. And so he is doing some manipulation there, and because he's doing some manipulation and changing things, that is going to be an experiment. Okay, really, if you take your time and read it, it's common sense, but you got to take your time and read it and pay attention to the scenario in order to decide whether it is going to be observational or an experimental. I want to focus on experimental for a few minutes because it is an experiment and you're performing that manipulation, there's more involved in the proper design for that. And again, typically you have to have at least 2 variables, and those 2 variables have names. The first one we call the independent variable. Some researchers use the word explanatory variable, but this is the variable or the thing that you're going to manipulate or the thing that you're going to change during the study, during the experimental research study. This is the thing that you're going to manipulate or change. In a sense, it's called the explanatory variable because the independent variable, or this particular variable, explains what is going on in the experiment. It's what causes your blood pressure to go down, or what causes the new filling that the dentist uses, the new material, to be better than the old material. So it kind of explains what's happening in the experiment. We often use the symbol, an X, for the independent variable. That's a carryover from our algebra days. We typically use X for the independent or the explanatory variable. The second variable, and again, you can have more than one independent variable, really. We will primarily be focusing on one, but you could have two independents or three independents. And the second variable is called the dependent variable, or sometimes it's called the response variable. It's called the response variable because it's kind of the result or the outcome of a treatment or manipulation. It's what happens when you changed that particular thing in your experiment. What was the effect? What did it cause? What was the result? This is the variable about what the researcher is asking about. This is the one that they're studying. That's the dependent variable. And more times than not, we often represent the dependent variable by the letter Y. And again, that's a carryover from algebra days. So we usually represent the independent with the letter X, the dependent with a Y. And again, the terminology, you can flip-flop between independent and explanatory, or you can use dependent and response. And different textbooks, different researchers are going to use differing words. So if you think about the setup of an experiment, you have to have, obviously, some experimental units. The experimental units are the individual object or the actual individual to be measured. Some researchers would call these your subjects. And that could be anything from an actual person to a survey or a questionnaire, and you're looking at the responses. Each one of the surveys would be considered an experimental unit. It could be, again, looking at past records from, say, the hospital or within the electronic system. And each individual report is considered an experimental unit. Then you have treatments. The treatments are the different values of the explanatory variable or the independent variable, the different things that you're going to try. Maybe you're trying to decide whether a certain type of diet or medication or exercise is going to help lower someone's blood pressure. Okay, so whether diet, that would be a treatment, medication would be a treatment, and exercise would be a treatment. Okay, so you have the different values of the explanatory variable. And again, we typically need to have at least two treatments. Continuing with the setup, so that you can have a way to tell what changes when you manipulate your independent variable, you need to have a control group. A control group is the group of subjects that do not receive any treatment, or they get what's called a placebo. A placebo is a neutral or a fake treatment. Okay, so you have to have that control group, and basically you don't do anything to the control group. Okay, so that you can see, okay, this is where that's kind of your baseline, so that you can compare what occurred to that group versus the other group or groups. You have the treatment group. The treatment group is the group of subjects that actually get the treatment. And again, you can have more than one treatment group. Okay, and you can have multiple treatment groups. You have one for each treatment. And ideally, when you're setting up these two groups, you want to randomly assign the participants to a group before you actually start the research. And you want to do that in a random way. Maybe you go, you number them off. 1, 2, 1, 2, 1, 2. And all the ones go in the control group. And all the twos go in the treatment group. Okay? But you randomly assign them to a group. Okay? That helps to control any kind of outside variables that may affect your results. Sometimes within research, the participants don't know which group they're in. They don't know if they're in the control group or if they're in the treatment group. And that's done to prevent or limit the effects of the suggestion. If I know that I'm taking the actual medication, then I may falsely feel like that something's happening, and it's really not true. When the subjects, the participants don't know which group they belong to, it's called blinding. Now, the researcher still knows that group A is the control group and group B is the treatment group, but the subjects don't know. Again, that limits those effects of suggestion. It's also possible, though, that the researcher and the participants don't know which group is which. And again, that helps to prevent or limit bias on the researcher's part. To maybe think, so the researcher won't think that something's happening and it's really not. When the researcher and the subjects, participants don't know which group they're in, that's called double blinding because they both do not know. So you got two groups and they don't know what's happening. It's called double blinding. You have to be careful anytime you're conducting research. There will always be lurking variables. Lurking variables are maybe one or more variables that aren't really as part of the research, but perhaps influences or affects the interpretation of the result. Sometimes it may be something that you don't know about, so you don't control it. Other times it may be something that you know about, but you just control it in that particular experiment, maybe because of time, various different kinds of issues where you just couldn't control that thing. So a lurking variable is again something that you're unable to control that may affect and influences the interpretation of the results. Okay, so I want to take some examples. A couple of scenarios here where you may be able to identify the explanatory variable, the response variable, treatments, and decide whether a particular scenario has blinding or not. So in this particular scenario, it says researchers want to investigate whether taking aspirin reduces the risk of a heart attack. 400 men between the ages of 50 and 84 are recruited as participants. The men are divided randomly into two groups. One group will take aspirin, and the other group will take placebo. Each man takes one pill each day for 3 years, but he does not know whether he is taking aspirin or the placebo. At the end of the study, researchers count the number of men in each group who have had heart attacks. Okay, so the first question that they ask us here is to identify the explanatory variable or the independent variable. Okay, and so if you think about what the question would be here, the question is, does taking aspirin reduce the risk of a heart attack? So my explanatory variable or my independent variable is taking aspirin. Okay? So my independent variable, the thing that I'm manipulating is whether or not the subject is taking aspirin. I want to know, ultimately, did they have a heart attack? Okay, so my response variable is a heart attack. Did they have a heart attack? I have really two treatments here, I suppose, because you have aspirin and you have the placebo. Okay, because it says one group gets the aspirin, the other group gets the placebo. Did this study involve blinding? Yes, it did, because this sentence right here says, he does not know whether he is taking aspirin or the placebo. So the participant did not know which medication he was taking. So there is blinding here. Second scenario. The Smell and Taste Treatment and Research Foundation conducted a study to investigate whether smell can affect learning. Subjects completed mazes multiple times wearing masks. They completed the paper and pencil mazes 3 times wearing floral scented masks and 3 times with unscented masks. Participants were assigned at random to wear the floral mask during the first 3 trials or during the last 3 trials. For each trial, researchers recorded the time it took to complete the maze and the subject's impression of the mask scent, whether they felt the scent was positive, negative, or neutral. So again, we want to think about what's our explanatory variable. And again, we're thinking about, does smell affect learning? And so our explanatory variable here is going to be the thing that we're manipulating, the thing that we're changing, which is really the mask, but what we're changing about the mask is the smell. Okay, because it says they do it with floral scented mask and then with unscented mask. So we're changing the smell. And all the participants do both things. All participants wear floral scented mask for 3 times, and then they wear unscented mask for 3 times. So the response variable is how long it takes them to do the maze. Okay, time to complete the maze. And we also have, and the impression of the scent. I don't know if that really affects learning or not, but you could include that as part of the response variable. The treatments would have been the floral scented mask and the unscented mask. Now, this particular study, I didn't ask the question about blinding, but guys, think about it. If I put on a mask and it's got a smell to it, I'm going to know it. And so I really couldn't, there's really not an opportunity for blinding here because the participant's going to know whether they're wearing a floral scented mask or whether they're wearing an unscented mask. And so this particular study does not involve blinding.